Welcome back. Happy New Year. I hope you had a great break. Yes, I had a great break too. Thank you for asking. So we're going to start right off here, but before we do, just got to note that Green Bay is going to the Super Bowl. Booyah. We're going to look at elements of power, and you should have your note sheet opened up right now. If you read through the top part, you're going to see that there's a section for equations, and then there's a section for notes. So you're going to want to kind of flip back and forth. This first piece here will be kind of in both. So let's start right out. Work is defined as force times distance, or F times D. In English units, it's measured in foot-pounds, and here's kind of an abbreviation for that. In metric, it's measured in Newton meters. And there is a short version for Newton meters. It's just called joules. So maybe pause this, just take a second to add those to your notes, both in the equations and down in the definition as just force times distance, kind of the same. Now let's take a look at power. Power is a measure of work being performed over time. It's typically measured in horsepower. And 1 horsepower is the amount of energy required to move 550 pounds 1 foot in 1 second. So write that down. I'll say it again. 550 pounds 1 foot in 1 second. So you're moving it 1 foot in 1 second. If you can move 550 pounds that far, then that's a horsepower. You are a horse. So it is also called torque power. If the motion is rotary, if something is spinning, then it's torque power. And it can be mechanical, electrical, or fluid. So let's move on. If you're going to calculate power, you would do work divided by time, because again, it's the amount of work over a period of time. And so you can jot this piece down. We have all of these units and words defined, so make sure you have all of that recorded. So let's go right on to an example. If Bob moves his 180-pound body up 6 feet of stairs in 2 seconds, how much work did he perform? So remember, P-Wiki this. I want you to get out a piece of paper, pause this if you need to, get out a pencil or pen and a calculator, and I want you to actually go through these practice problems. It's going to make things way easier for you in the future if you've actually gone through them. So work, again, is force times distance, and your force is 180 pounds. Your distance is 6 feet. So when you multiply those together, you get 1,080 foot-pounds. Your time is 2 seconds. So this is the what you know part of P-Wiki. Should have a little picture here of Bob walking upstairs. And then what you know is you know the force, and you know the distance, and you know the time. So power is force times distance divided by time, 1080 divided by 2, which is 540 foot-pounds per second. Now you're also going to need to calculate this in horsepower. So to do that, you take your power in foot-pounds per second, divided by 550 foot-pounds per second per 1 horsepower. You're just converting that, and you get 0.98 horsepower. So let's move on to your example. And on a sheet of paper on your own, I want you to do this problem. It's an escalator moving 60 people per 1 minute. We're not talking seconds here, we're talking minute. So you have to do some conversions. From one floor of the mall to the second floor, the mall's floors are 20 feet apart, and each passenger weighs 150 pounds, but there's 60 of them. How much power does the escalator need to be able to accommodate that? So please pause it, or go back a slide if you need to, and pause it on that so you can see an example. Really want you to practice this and try to do this on your own. So go ahead and move it back or pause it now and see if you can get the answer. So hopefully you got a chance to do this, work this out. You drew a picture of an escalator with a bunch of little circle heads going up the escalator. And let's define what we know. We know that the force is 150 pounds per person. There's 60 people, you get 9,000 pounds. The distance was 20 feet. So when you multiply those together for work, you get 180 foot-pounds. The time is 60 seconds because it's a minute. That's 3,000 foot-pounds per second. And when we divide that by 550 foot-pounds per second for 1 horsepower, we get 5.5 horsepower. So hopefully you got both of these as your answers. If it didn't work out, if you're not really sure what in the world's going on, pause this, raise your hand, have me come over and help you out. That's what I'm here for. All right, let's move on to electrical power. So electrical power is measured in watts. It's still power, so this is kind of that funny situation where electrical power is measured in, they use the metric version for power in watts, whereas mechanical power, we're going to be using the English version, which is horsepower. You can convert horsepower to watts, so write this down. 1 horsepower is equal to 745.7 watts. Again, 1 horsepower is 745.7 watts. So if you go back 5 horsepower, or 5.5 horsepower, is this number times 745.7 watts. So it's going to be 5 times 750 is like 4,500 or something close to that in watts. Watts has the greatest variety, I suppose. There's lots of different things that use watts here, all this electrical things. And it's a measure between, relationship between voltage and amperes or current. So here's your equation for it. P equals E times I. It's a little weird because voltage can also be written as E. A lot of people will see it as V. Makes more sense that way. But it also can be written as E, so pause this, make sure you have that noted down. Current is almost always written as I. For current, the units for current are amps. The letter to abbreviate current is an I. The units for voltage is volts. The letter to abbreviate it, we're using a V. A lot of times it's a V, sometimes it's an E. And for power, the units are watts, and P abbreviates that. So let's get to a practice problem. If your house is wired so a typical circuit can handle 15 amps, which appliances can be used simultaneously without blowing a circuit? Really, it'd be more like tripping the breaker. So let's take a look at what we have here. We've got a hairdryer, microwave, toaster, coffee maker, dishwasher, flat iron. And this is how much power they're using and how much voltage they're using. So you actually have to solve for current. We don't have an equation to solve for current, but check this out. So I have this thing I like to call the magic triangle. When you have an equation with 3 variables, if you make this triangle here, and you have 2 that are being multiplied together, E times I, then those go on the bottom. It's E times I. The remaining one goes on the top. Now what this allows you to do, this is sweet if you haven't seen this, is if you want to solve for I, sometimes your brain might get confused about which one do I divide by. Makes this really easy. Whatever variable you want to solve for, you just cover it up. If I want to solve for I, or current, then it's power divided by voltage. Boom! Check this out. If I want to solve for voltage, it's power divided by current. And if you want to solve for power, voltage times current, just like we have here. And if you want to prove it, if you have P equals E times I, if we divide both sides by E, those cancel. You have I equals P over E. I equals P over E, or power over voltage. So it works. So this little trick can also be applied to any equation with 3 variables. So you have power equals work divided by time. So we can make our own little triangle here. And work divided by time, that means that work is on the top because it's on the top here. So whatever variable, if you have one on the top, goes in the top. If you have 2 being multiplied over here, then you put those down at the bottom. So work is on the top. Doesn't really matter where these go, but since P is on the left, I'm going to put it there. That's T. So power is work divided by time. Time, because this gets a little bit tricky if you want to solve for time. Time is work divided by power. Makes it really easy. And work is power times time. They're both on the same row. You're multiplying. So just keep that in mind. That'll make these a whole lot easier for you.